Okay, welcome to your business calculus lesson 1.1 on linear functions. This is Mrs. Brown, and I am here today with my trusty sidekicks, my dogs, Scout and Daisy, and we are ready to talk about lines. So we're going to review how to find the slope of a line and also talk about writing and graphing the equations of lines in various forms. All right, so if you'll recall, the slope is rise over run. As you can see on this picture here, the rise is the change in the y values, the vertical change, and the run is the change in the x values, the horizontal change. So if we want to find the slope of the line containing the points -4, 6, and 8, -4, we need to pick one point to be 0.1 and the other to be 0.2. I typically choose the first point to be 0.1 and the second point to be 0.2. And so my change in my y values is going to be -4 minus 6, or -10. And then my change in my x values is going to be 8 minus -4, so +12. -10 over 12 reduces to -5/6. Since we were just asked for the slope, we are done. Okay, one of the things that people expect from high school graduates, especially high school graduates from a college prep school, is that they know the all about lines, and so certainly they know the common forms of equations of lines. So there's slope-intercept form, point-slope form, and standard form, and you need to know those. And then you also need to know that horizontal lines are y equals a constant and vertical lines are x equals a constant. Okay, so we want to find the slope and y-intercept of y equals 4x plus 7. So it's helpful to stop for a second and consider what form of the equation of the line that this is written in, and it is written in slope-intercept form. And our slope is represented by m, and our y-intercept is the point 0b. So from our equation, we can read straight off of it that the slope is 4 and that b is 7. So again, the slope is 4 and the y-intercept is 0, 7. Okay, now we want to write the equation of the line through to 4 with a slope of 3 and point slope form. So point slope form, remember, is y minus y1 equals m times x minus x1. M is still the slope. X1, Y1 are the specific values from the point, and then plain X and Y are our variables. And so we're going to plug in 4 for Y1 and 2 for X1. And so we're going to have Y minus 4 equals 3 times X minus 2. Since it asks for point slope form and we are in point slope form, we can stop. But what if we wanted slope intercept form? We could keep going, and we would distribute the 3, and we would have y minus 4 equals 3x minus 6, and we would add 4 to both sides to get y equals 3x minus 2. Okay, now we want to find the slope-intercept form of the equation of the line through 3, 1, and -1, 7. We have to know the slope, so we're going to find the slope first. Again, we'll consider the first point as x1, y1, and the second point is x2, y2. And so we're going to do our change in y values, so 7 minus 1, over our change in x values, so -1 minus 3. So we have a slope of -6/4, which reduces to -3/2. Now, you could pick either point. Since I've already considered x1, y1 to be 3 and 1, I'm going to use those. And so we have y minus 1 equals -3/2 times x minus 3. So we're going to distribute the -3/2 to get -3/2 x plus 9 over 2. Negative times negative is positive. And then 3 times 3 is 9. And then 2 times, if you want to put a 1 under the -3 there just to make it easier, you do a 2 times 1 is 2. And then we want to add 1 to both sides. And so we want to consider 1 as 2 halves. 9 halves plus 2 halves is 11 halves. So we can see what our slope is. Our value for b is 11 halves. So we are in slope-intercept form. Okay, so if we use slope-intercept form to graph an equation, you'll what you will do is you will plot the y-intercept, and then you'll use the slope to get a second point because it takes 2 points to define a line. So when we have y equals -3 halves x plus 1, we'll start by plotting the point 0, 1, and then we'll use the slope of -3 halves to get a second point on the line. So we'll go down 3 and to the right 2, and then we'll play connect the dots. And you'll notice that it goes up to the left, which is what we expect from a line with a negative slope. Could we graph an equation that was in point slope form using a similar process? We sure could. We would plot the point x1, y1 wherever it is. So say this point here was, we had 2, -2 as our x1, y1. We would plot that, and then we would use our slope -3, 2 to plot a second point, and then we would graph the line. Okay, when an equation of a line is in standard form, one way to go about graphing it is to find the x-intercept and the y-intercept. One thing that people sometimes struggle to remember is that for the x-intercept, you let y equal 0. Okay, remember x is going to be interesting for the x-intercept. Y is going to be 0. And then for the y-intercept, y will be interesting, x will be 0. So we've got 2x plus 3y equals 12. All right, so let's find the x-intercept. So we let y equal 0, and we're going to get 2x equals 12, which gives us x equals 6. So we plot the point 6, 0. Then we come back to get our second point. We let x equal 0, and we solve for y. So we get 3y equals 12, which we can divide by 3 and get y equals 4. So then we plot the point 0, 4. We play connect the dots, and we have our line. Okay, please recall that horizontal lines are of the form y equals k, and they go through the point 0, k. And vertical lines have an equation of x equals k, and they go through k, 0. So if I want to graph y equals -1, I plot the y-intercept of 0, -1, and then I just draw a horizontal line through it. And if I want to graph x equals 2, I come over here to the x-intercept 2, 0, and I plot that, and then I draw the vertical line through 2, 0. Okay, guys, that's it for today. Go ahead and look at your problem set and see, if there's anything that you can get started with. If you have any questions, please feel free to email me or swing by my classroom. I'm always happy to help. Thank you and have a good day.